Welcome to homework.
The distribution of x, which is the height of the individual, is given as approximately normal. Okay. So, where 64 is the mean and 2.4 the standard deviation. Not 6.4, 64. To find the probability that the person's height is between 61.1 and 62.4, we need to calculate the cumulative probability using the standard normal distribution. First, we need to standardize the values using the z-score formula. So our first z-score would be 61.1 minus the mean 6.4, 6.4, but 64 over the standard deviation 2.4, and the second z-score would be 62.4 minus 64 over 2.4. So 61.1 minus 64 over 2.4 is negative 1.208. I'll go for it. That's one basis. And our second z-score is negative 2/3. Next, we use the standard normal distribution table or calculator to find the corresponding cumulative probabilities. So the probability that, it would be the probability that negative 1.283 is less than z is less than negative 0.6667 into a calculator. We get about 0.1390. So the probability that a person's height is between 61.1 and 62.4 inches is about 0.1390. The middle 20% of Martian heights lies between what two numbers? To find these two numbers, we need to determine the z-scores that correspond to the lower and upper percentiles. So first we find the z-score that corresponds to the lower percentile. So that'd be the probability that z is smaller than our first z-score, which would be 1 minus 0.20. Over 2, which is 0.4. And using a standard normal distribution table or calculator, we can find the z-score corresponding to the cumulative probability of 0.4 to be 0.2533. And next we do this with the upper percentile. So that would be the probability that z is smaller than our second z-score, which would be 1 plus 0.2 over 2, which is 0.6. And using the standard normal table or a calculator, you can see that this is positive 0.2533. And now we use the z-score formula to find the actual values of the Martian heights. So the lower boundary would be the 64 plus the negative 0.2533 times 2.4, because that's the standard deviation. And that is about 63.3921. you can round appropriately. The upper boundary would be 64 plus 0.2533 times 2.4. And that is 64.6079. So the middle 20% of Martian's heights lie approximately between these two values.